We continue with image analysis and basic processing. Now moving on to VOI-based masking. This is a common use of VOIs, and it can be used to prepare images for presentation. It's common for most modalities. In the case of PET, high activity in areas that aren't interesting could be masked to allow presentation of the image with more focus on the tumor. For CT, a common task is removal of the bed and the associated hardware. And for MR, common task could be removing tissue outside the brain so that we can use the brain atlases more effectively. The tools for VOI masking are conserved throughout the PMOD tools, mainly available in the Tools tab for VOIs. As an exercise, we will use the View tool and we'll use cleanup of a CT image as an example. So again, we'll use the subject pseg2. We can use the filter for the database, entering PS and pressing enter to update so that we see a shorter list. And then we select pseg2 PET CT. And now we will select the CT series from the list, add to our loading list and open. The MIP can be switched back into normal grey colour scale, then we see whitish bones and high density elements as we expect for CT. And we see that the teeth and the ring are the densest part of the image, followed by the bones. This means that if we were rendering the skeleton alone, this could already be quite effective even without doing any extra masking. But the bed materials have a similar density to the soft tissues, which is why we don't see the outline of the body very clearly in the MIP. And this will make a whole body rendering, particularly a volume rendering, rather unattractive. So when there's some separation between the subject and the bed materials, like when the bed has a typical foam mattress, then separation using simple VOIs can be quite straightforward. If we triangulate a location in the center of the image, we can see the bed hardware below the subject, and we can see a gap where that foam is with low density appearing black on the CT, meaning that we can do segmentation using that gap to our advantage. It's convenient when the image is fully horizontal, as we see here, but even if it's not, if there's been some deviation in the bed, then PMOD's reslicing tools can be useful to realign the image. Now we can proceed to the VOIs tab. First of all, we'll explore the image a little more to understand where we need to be careful not to crop the image artificially. If we see the MIP, this suggests that at the level of the elbows the image will be the widest, and there's already been some cropping in the acquisition. If we triangulate a location there, make sure that the VOI mode is neutral, then we can see that the arms are the widest point of the image, along with this separation underneath the body that we saw on the last page. So we need to draw custom VOI using that gap to our advantage, but making sure that we include the arms properly. It can be useful to change the image display to show only the axial slice for this operation. Z plane. Here we see the gap underneath the patient particularly clearly. And we can use the vertex paintbrush tool to draw a 2D ROI around the body on the axial plane now, wide enough to include the arms. So the vertex paintbrush tool is near the top of the VOI controls, and then we can left click and freehand draw a contour, including the arms, passing through the gap underneath the subject, and circling back around to complete the contour. Now we can return to the orthogonal planes display, and we can also turn off the display of the peak concentration. And we see that this contour we drew only applies to a single slice at the moment. So that we can apply that to the whole body, we can use a shortcut on the Contours and ROIs panel, which is accessed using the drop-down arrow at the bottom. where we find ROI apply to all. After short calculation, we now see that our ROI has been copied to all of the axial slices in the image, meaning that we can use this for masking of the whole body. If we return to the VOI's neutral mode, the cursor at the top of the tools, then we can navigate through the image to see how our contour corresponds to the outline of the body. To apply masking, we go to the VOI Tools tab, where at the top in the data modification area we have a number of possibilities. Where mask is indicated, we see the option to mask outside the selected VOIs, and we should know which value to use. Since we're working with CT data, the background and air should have a value of -1000 Hounsfield units, and we can check that using the data inspector. So we see that the values in the air outside the subject are exactly or close to -1000 Hounsfield units. This means that when we open the mask outside our VOI tool, we can enter a value of -1000 Hounsfield units. We should not mask inside our VOI because we want to keep the CT data as it is. And if we create a new study, then we can directly compare the original data and the masked data. We see the calculations proceed in the lower right, and then we see the image update with an immediate update of the MIP as well. If we wish to repeat this process, we can save the VOI, and if we're confident that it can be easily re-achieved, then it's not necessary. So for now, I will delete my VOI, and to compare the masked image to the original, I can proceed to the comparison page. We have a workflow button in the lower right. Here we see a comparison of the available images in the memory, and the third row is a duplicate since we only have 2 images available. So that third row can be turned off using a shortcut at the lower right of the image display, selecting blank row, and then we can focus on the 2 images, the original and the processed image. We can hide the remaining contour of the VOI using the shortcut in the lower right of the image controls, and then we can see, particularly in the MIP display, that we have more clarity in the body outline. Here we see the gap between the abdomen and the arms in the middle row, and we can see that the bed was clearly removed. This process could be repeated, targeted around the head to remove the head support that is still present and that appears in the MIP. And for later examples, we've done that for you. For now, I can return to the view page, make sure that I have my masked image selected, and then I can save the image back to the database to be used later if I want. So I should change the save mode to database. I can edit the information in the header. PMOD has already indicated this was VOI masked, and we can always add information to make clear that this was for the body at this stage. Then we can confirm and save our image back to the demo database.